Okay, have you ever stopped to think about what connects a kid's birthday balloon to a super advanced, life-saving MRI scan? The answer is this surprisingly rare, really important element. Today, we're diving into helium, a noble gas that's super light but plays a seriously heavy role in our world. Yep, you probably guessed it, it's helium. But this is about way more than just party tricks. Helium is the second lightest element in the whole universe, and its weirdly unique properties connect everything from the fiery heart of the sun to the unbelievably cold world of quantum computing. And right there, that's the central problem with helium. It's incredibly useful, but it's also a cosmic escape artist. I mean, once it's released, it's so light that it literally just floats away, off into space, gone for good. That makes it a precious, non-renewable resource, and, well, we're kind of running out. So how can something so incredibly light carry such heavy importance? Let's get into it. Look at this number. That's roughly the entire planet's annual production of helium these days. That's it. And that very limited supply has to power every single MRI machine, every semiconductor factory, and every rocket launch on Earth. So this brings us to the big question we're trying to answer in this explainer. Is helium a true A-tier enabler of modern science, a real hero material? Or is its extreme scarcity a fatal flaw that's holding it back? To really appreciate helium, you've got to know its origin story. We need to go way back, from its discovery in the sun to its big break in 20th century air travel. So get this, for almost 30 years, we thought helium only existed in the sun. It was discovered there first, but once we finally found it here on Earth, its first major job was in airships as a much safer alternative to hydrogen. But the real revolution, that came in the 1980s, when its incredible cooling power became absolutely essential for MRI machines. And this is a perfect example of why that matters. We all know the Hindenburg disaster. That happened because the airship was filled with super flammable hydrogen. The crazy thing is, the United States had tons of safe, non-flammable helium, but because of politics, they wouldn't sell it to Germany. It's just a powerful, tragic reminder of helium's unique, life-saving properties. So what is it that makes helium so special anyway? Well, it all really comes down to two incredible superpowers. First, it gets mind-bogglingly cold. Helium has the lowest boiling point of any element, just a couple of degrees above absolute zero. That's the coldest temperature that is physically possible. This makes it the ultimate coolant for those powerful magnets in MRIs and giant particle accelerators. And second, it's a noble gas. Inert is just a fancy way of saying it doesn't react with, well, anything. It won't burn, it won't cause corrosion, it won't interfere. It just keeps to itself. And that makes it perfect for creating these super clean environments you need for making sensitive stuff like computer chips and fiber optics. This chart shows you where all that helium is going. Almost a third of the entire world's supply is just for cooling MRI machines. Think about that. That one application tells you everything you need to know about how vital helium is to modern healthcare. Without it, the MRI scans we rely on today just wouldn't be possible. But for all its amazing uses, helium has one giant weakness. We've been hinting at it, and now it's time to face the problem head-on. Our planet is running dangerously low on this stuff. This comparison really gets to the heart of the issue. Hydrogen actually has more lifting power, and it's the most common element in the universe. But it's explosive. Helium is perfectly safe, but on Earth it's incredibly rare. And that right there is the dilemma. Yeah, helium's weaknesses are a really big deal. It's non-renewable. Gone means gone forever. The supply is basically controlled by just a few countries like the US, Qatar, and Russia. So if one of their plants goes down or they change an export rule, the whole world can face a shortage. Plus, it's a huge pain to store as a liquid. It's just a recipe for constant supply problems and wild price swings. You know, I think this quote from our source material just sums it up perfectly. For an element that's all about being light, it sure comes with the heaviest baggage when it comes to supply. All right, so what's the final verdict? We've seen its incredible strengths and its major weaknesses. Time to see how it all adds up on the scorecard. Okay, taking a look at the scores. It does really well on its unique properties and versatility. That 9 out of 10 for mechanical properties is all about its superpower as a coolant. But then you see it. Scalability and cost gets only a 5 out of 10. Ouch. That one factor, the fact that it's just fundamentally rare and expensive, drags the whole score down. It's a huge problem you just can't get around.
And that brings us to the final ranking, a solid B tier.
So why B tier? Look, it can't be A tier. You can't be a top-tier material if the world is always worried about you disappearing. But it is way above C tier, because for those critical jobs like cooling an MRI, there is simply no substitute. It's a vital, irreplaceable specialist that just happens to have some serious limitations. Here's a really good way to think about it. If an element like lithium powers the future, then helium cools the future. All that next-gen tech we're excited about, quantum computers, fusion reactors, a lot of that stuff simply doesn't work without the one-of-a-kind cryogenic power that only helium can provide. So helium doesn't build our world like steel or concrete, but what it does is let us see inside it, whether that's inside the human body or into the fundamental laws of physics. And that leaves us with a really big final question. How can we possibly be better stewards of an element that is literally vanishing forever? Because the future of medicine and technology really does hang in the balance.